Problem number 8 is asking you to factor completely, right? And factor completely means use whatever means you have to break down this expression as much as you can break it down, right? And we're going to leave the expression. So again, let me reiterate, this is not a problem where I'm going to ask you to set anything equal to 0 or solve anything. Factor just means get to the step where you can't break it down anymore and you're done. Okay, so taking a look at this first problem, number 8 here, okay, it looks like when we start off, there's a GCF. In this case, there's a 3 in each of these values. So if when I pull out a 3, okay, I'm also noticing that there's one x in common that I need to remove as well, right? So I'm going to remove that and say 3x, okay, and it looks like I'm left with 2x squared minus 17x plus 35, okay? This expression on the inside is a quadratic trinomial with a 2 at the beginning, so that's a problem where you're going to have to use AC factoring, and you're basically saying what numbers multiply to 70 that add up to negative 17. So your answers to that are, if you were stuck, it was negative 7, okay, and negative 10. So I'm going to just remove or show you this split step here, okay? And then I'll trust that you can, from here, do all your grouping and regrouping and get your final answer, which should be for problem number 8, okay, 2x minus 7 and x minus 5. So that would be the final answer. You don't need to go any further than this right here. Okay, this is your answer. Okay, we're not setting these equal to 0. We're not solving them any further. We're stopping right there. Okay, problem number 9, very similar. Okay, I'm going to say there's a negative 9 factor. Okay, negative 9x squared. Right? And it looks like I have x squared plus x minus 2. This one's even easier because there's no value in front of x squared. I can just say what multiplies to negative 2 that adds up to 1? Well, in this case, x plus 2 and x minus 1. And don't forget to bring the negative 9x squared down. Again, I'm finished in one quick step here. I would say this is my factored expression. Okay. Problem number 10 also has a GCF, in this case 5x to the 4th, okay? And here's my new problem, x cubed minus 2x squared minus 16x plus 32, okay? Now the term on the inside, the 4-term expression, that can be done via grouping. So if you notice, this problem number 8 up top, when we did the split in the middle, we ended up with a 4-term expression, and this is where you did grouping and GCF and regrouping. We're going to do that exact same thing on this problem. So again, I'll trust that you can do that. Okay? And when you do your grouping method properly, you get x squared minus 16 and x minus 2. Okay? Here's where you have to be careful. My directions at the top said factor completely. Okay? What factor completely means is if you can break anything down using a factoring method, you have to do it. So in this case, x squared minus 16 is the difference of two squares. This can turn into x plus 4. And x minus 4. Okay, I have the x minus 2 that's at the end. Okay, and that 5x to the 4th that we pulled out at the beginning. So I actually end up with 4 terms that come out of this expression in my entirely factored form. Okay, problem number 11 is another example like we just did, where I have a 4-term polynomial. There's another GCF, in this case x squared, that I can remove. Okay, so I'm left with 4x cubed, okay, minus 20x squared minus x plus 5. Okay. Another grouping problem. So again, I'll let you go through and group and regroup. What you end up with is 4x squared. Okay. The second group only has a minus 1 in common. And my leftover, that common leftover, was an x minus 5. Okay. And again, you need to be careful. This 4x squared minus 1 expression, just like x squared minus 16, is the difference of two perfect squares. So I'm going to say 4x squared minus 1 is going to turn into 2x plus 1 and 2x minus 1, okay, using the difference of squares. Using the exact same reasoning that we used for x squared minus 16. This is x times x and 4 times 4. This is 2x times 2x and 1 times 1, which is why the 2x and the 1 are showing up in both of these examples in the bottom. Okay, so in these first two sets of problems, it's GCF and AC factoring. In my second two problems, it's GCF and the grouping method, and then we had to be careful because when we did the grouping method, and this is going to happen fairly frequently, that one of the factors might break down again, and you just have to look out for it. Okay, so let's take a look at a few more factoring. These two factoring problems don't look like the other ones. They are binomials. They only have 2 terms, and they're cubic. Okay, so these are the problems where we have two formulas. Let me write them down for you. We had, if you can write something as, okay, the sum of two cubes, that you're going to be able to factor that into a plus b. And then the second one is a squared plus ab. I'm sorry, let me fix that. A squared minus ab. This wants to work. Okay. A squared. It does not. Oh, I got it. Okay. A squared minus ab plus b squared. Sorry for the technical difficulties. All right. Second one is going to be a cubed minus b cubed turns into a minus b. And then the second one is a squared plus ab plus b squared. Okay, so I'm going to look to turn problem number 12 and problem number 13 into these expressions, but problem number 12, I actually have a little bit of extra to work with. There's actually a GCF right at the beginning. 8 and 64 have an 8 in them, so I'm going to remove that. And this is going to turn this into x cubed minus 8. Okay, I'm going to look at the x cubed minus 8, and I'm going to say x cubed minus 8 is really like x cubed minus 2 cubed, so it fits this second model, right? A cubed minus b cubed. So I'm going to turn this piece right here into the things that are being cubed are x and 2. So everywhere that I see an a, right, I see it several times, I'm going to put x. Everywhere that I see a b, I'm going to put a 2. So here's what it's going to look like. X minus 2. And in my second expression, it's going to be x squared, okay, plus 2x plus 4. Okay? And then don't forget that we had an 8 at the beginning, that you include that as well, right? So my final answer, 8x minus 2, x squared plus 2x plus 4, okay? The second one is the same thing, except it's going to use the first formula instead, and that's because we have a plus sign up there, right? So I'm going to say this is really x cubed plus 1 cubed, right? And I can rewrite this as x plus 1, and x squared plus 1x I'll just write as x. Okay, and when I square 1, I also get a 1, right? So it's going to look exactly like that, okay? And again, I'm making the same mistake. There is a minus sign in the middle here. So watch your signs. Okay, use the formula correctly. There's a minus sign right there, okay? As the formula says, there should be a minus sign before the AB, okay? Problem number 14. State all of the factors of 2x to the fourth plus 5x squared minus 5x squared minus 7 if 2x squared plus 7 is a factor. So in this case, this is one of those problems where we're basically saying, if I tried to factor this 2x squared plus 5x squared minus 7, I don't have any methods that would work. There are no AC factorings or grouping methods or anything else that works. So I'm actually going to have to take this problem and use long division. I'm going to need to divide away the 2x squared plus 7 and see what's left over. So let's try that out. Okay, so 2x squared. And when I write the divisor on the outside, I'm going to say there's not an x to the first in my divisor. Right? I don't have a 0x to the I don't have an x to the first, so I'm going to put a 0x plus 7. Okay, and then on my divisor, on my inside of the long division symbol, I'm going to do the same thing. I'm going to say 2x to the fourth. Okay, I don't have an x cubed, so I'm going to put 0x cubed. Okay, plus 5x squared. Okay, I don't have an x to the first, so I'm going to put 0x minus 7. Okay. And now we're doing long division. So I'm going to say I need to turn 2x squared into 2x to the fourth. I'm going to do that by multiplying by x squared. Okay? So I'm going to say x squared times 2x squared, that's 2x to the fourth. Okay? X squared times 0x is 0x cubed. X squared times 7 is 7x squared. All right, let's do our subtraction. Okay? So 2x to the fourth minus 2x to the fourth cancels. 0x cubed minus 0x cubed is still 0, so I'm not going to bring anything down for that. 5 minus 7 is going to give me negative 2x squared. I'm going to bring down the next term, 0x. Okay, I'm saying, okay, I need to turn this expression into this expression. Okay, and it looks like there's nothing in this second spot, so I'm not going to do anything at all, right? I'm going to say there's basically a minus 1, right? Negative, if I put a negative 1 up here, okay, negative 1 times 2x squared is negative 2x squared, okay? Negative 1 times 0x is 0x, okay? Negative 1 times 7 is negative 7, so I'm going to bring down this negative 7 so I have something to subtract with. You can bring down more than 1 at once if the multiplication calls for it, okay? So if you notice, this all goes away, and I end up with a 0. Okay, so I don't have a remainder. So it looks like after I divide away 2x squared plus 7, I'm left with x squared minus 1. Okay, x squared minus 1, if I'm being asked to state all of the factors, x squared minus 1 turns into x plus 1 and x minus 1. For the same reason that we've done before, where like x squared minus 16 turn into x plus 4 and x minus 4. This is one of those difference of two squares. So problem 14 asks for me to state all of the factors. So I'm going to state 2x squared plus 7. That was a factor. That was the one they gave me. And then I just found that x plus 1 and x minus 1 are also factors that came from the answer to the division problem. I took x squared minus 1 and I broke that down some more.